så har jeg laget meldt godt, og så var det sådan opfatter ret mindst mere. Og nu skal jeg
Right. Okay, guys. So, professional programming this week. Yay! Okay, so what I was looking at for this week, and one of the things I was looking at that might be interesting is discussing how to integrate with services. So we were going to be potentially doing some stuff with Discord, but that fell through. So I was thinking of looking at the Google Sheets API and how you can the idea of programming against APIs and integrating with other systems, and also potentially discussing libraries. Because how many of you have written code and compiled it as a library? One. Okay. So when you compiled code as a library, what kind of library code did you create? Right? Yes, I have started talking. But yeah, so you started doing, you did a library for binary trees and you used Visual Studio, and you told Visual Studio to compile a library, and it compiled this thing for you. It was a DLL. Yep. Okay, so we can discuss, because I thought also, you guys have worked with DLLs, right? And .libs, maybe. Yep. So you've used libraries, but you've not made libraries. Why not?
Those other people are so much better at it than we are.
Well, see, that's one of the things that, like, in this whole game of becoming a professional, right? Part of what you need to do is role play like a professional, right? So sometimes you just have to pretend to be the professional and do the things that professionals do, and then suddenly you do that for long enough, and everybody thinks you're a professional. Actually, how at my university, I was part of the computer science department, right? And the head of department got the position of being head of department by signing a letter with Director of Computing. No one had given him the title. He was just in charge of the computer they had, because this was in the 80s. They had one large computer in one massive room, and he was kind of an academic from the math department who'd been put in charge of it. And so he started signing his letters as Director of Computing. And people started referring to him as the Director of Computing. And so he then kind of created himself a department by just saying, right, I'm the head of this. And other people, oh yeah, well, he's the head, so he must know what's going on. So he faked it until he made it. And so to some extent, pretending to be a professional, rather learning to be a professional, partly is just, you know, taking the role of being professional, right? And so one of the things, as you said, a rite of passage could be considered building a library package, right? And so you code up a library and you are able to deploy it. Now, there are two types of libraries. So we'll talk a wee bit about libraries before we go on to connecting to an API, right? Because an API is a bit like that. Libraries and APIs are connected, right? Because libraries give you a bunch of functions that have already been compiled and a kind of interface to them, right? And so APIs are like that, but for whole systems. So they're usually running independently of you, right? So you've got an API to a running system, whereas a library is something you include into your project, right? A bit more tightly. Okay, so what's a DLL? A dynamic linked library. Why do we have DLLs?
So you don't need to compile the entire library into your code.
Okay. Why are they dynamic? so you can reference them on runtime. What's the benefit of referencing them on runtime? Faster than being static. Surely I could reference a static library at runtime. I could say I want that, like, static library is going to be pretty fast. You can switch it out. The original idea of dynamic linked libraries was the idea that, you know, if I'm going to have an OpenGL, a graphics library, right? If I go from graphics OpenGL 3 to 3.1, right? It'd be nice if I could change the library in the back end and its implementation without having to recompile my program. Because so long as I'm using the interface correctly, how you implement the back end is up to you. So if that gets improved, if it gets made faster, all those sort of things, that's fine. I should be able to swap that in and out. That was the idea. And so the thing would be that, you know, you'd have one library for SDL on your computer. And when it got updated, you'd just update the dynamic library and everybody would be linking to the dynamic library. And so I wouldn't have to have 50 copies of the code across every application like I would if it was static. I'd just have all of that code in one place and everybody would be reusing that one piece of code. Does it feel like that actually happens? If you look at the DLL library in your computer, how many files are there? I think you'll find a lot. And you know, when you uninstall a program, one of the options it gives you is, do you want to delete the DLLs connected to it? Have you done this? Or when you uninstall a program, one of the things you might find that it will do is when you install a program, it installs itself and the DLLs that it needs, it grabs them off, installs those into the Windows directory. I then remove the program, but all of those DLLs are still there. Right? Now, one of the sneaky attacks into people's machines was to override a known DLL. When you download the program, it overrides a known DLL with its new DLL, which does mostly the same things, except, you know, when you call a password check function, it also copies whatever you type out to a third party or something. So it, you know, it adds some malicious code to a DLL. Right? So the first thing virus checkers did is, right, list all the known DLLs, check that your signature matches the known signature. If it doesn't match, go, oh, virus, 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 malicious code, malware, right? But the idea was that because DLLs were this dynamically linked thing that could be replaced, so that you could refer to a new version later, if somebody did, it was designed to be updated, which means you could overwrite what was there by design. Right? This was intentional. So dynamic link libraries are just libraries that have this idea of saying, well, I've got an interface to them, which are the function calls, and the function call prototypes, like what the function calls look like. And then however you code the DLL in the back end, don't care. Right? So long as I give you this function, you give me this data back, we're all square. Right? And as a programmer, you can program those libraries. So I was thinking, as a rite of passage, it might be nice to get you guys to write some libraries. Part of writing libraries is also deciding what library you're going to write. Usually the simplest one is to write something like a vector library or a math library or something like a very, very small library that has a few functions. Right? And what you do when you're programming a very simple library is that you have no main, right? Because you guys are all used to writing a main loop in your C++ code. A library doesn't have a main loop. It just has functions, right? Because, you know, it's just going to have some functions that you call. Now, if you're going to do, so you have two types, dynamic libraries and static libraries. Static libraries, all the code gets incorporated into the program when the program is built as an exe. Dynamic libraries, you have an interface, the .h files, and then you have the dynamic linked library files are going to be somewhere else, right? So you're going to have to build those as a dynamic linked library file. Oops. Nope, I'll ignore that. I don't even know who they are. So as a programmer and as programmers, which library, so I'd like this to be connected to something you're doing, right? So rather than step you through an independent library at the moment, it would be potentially useful to get you guys to identify where you can write some library-like code in your projects, right? And say, are there bits of my code, as again, thinking professional programming, are there bits of my code that I could take out and say, well, this is actually generic to multiple projects. I could then take it out and make a library of it so that I could use it with this code, or I can use it in other code. Right? Because one thing is to make an example little library file, which is just, some math functions. But another is to look at the code that you're currently working on, work out, are there generic components that I know could be reused? What library would that make? Right? Can I modularize my code in that way? Right? Now, in that process, you then have to create an API. So the other thing we're going to talk about here is APIs, and discuss some API design and some API examples. So I take it you've all used APIs before. What's been your favorite API to use? Which one have you hated?
Unreal Engine, C++ API.
The Unreal Engine, the C++ API. Yeah. It's pretty heavyweight to get them linked together, isn't it?
Yeah, it's very lightweight, so they don't always define exactly what the functions does. So yeah, you code in the blind.
So coding against undocumented APIs, it's not uncommon. It should be uncommon, but actually, so there are an area of an APIs, and you get this when you're including libraries as well, right? So this is why I'm discussing libraries and APIs together, right? So you can imagine you would write yourself a library, right? And you'd have function calls, and you'd make some of those function calls, you'd kind of have the prototype, you do the nice proper thing of having your .h file with all the descriptions in there and stuff, right? And then, you have that file there. You do your Doxygen, your automated commenting system. So you guys have looked at Doxygen, JavaDoc, you do that over it. Then a few days later you think, oh yeah, I'll just add that version of the function. You go in there, you add that version of the function, you add it to the .h, you update the version, and you can't be bothered rerunning your Doxygen JavaDoc to generate a new documentation file, because you don't really expect anyone to use this particular version of the function. It's just for your internal use, right? It just happens to be there now, right? And nobody knows about it, right? And so it's okay. Goes out to production. There's documentation. That's all fine. People are using those functions. That's reasonable. But then there's this other function that is in there. It's just you don't tell it. No one's been told about it. And sometimes people find those and they go, oh, I found an undocumented feature. And yes, there are plenty of programs that have undocumented features in them. And sometimes that's fine because it's just a faster way of doing something. Sometimes those are things like cheat codes and hacks that get you past certain things in ways that they shouldn't. Right? One of the dirty hacks that Mariusz found this week, which took him a couple of hours, took him 5 or 6 hours to find, was that in Angular, so a library, inside that library, one of the hacks that had been done was that any string that looked like an object ID identifier would be automatically converted to an object ID internally within the library. So this was any string that was 24 characters long, exactly 24 characters long, and were solid characters with no spaces, right? So with numbers and letters, right? So if it was 24 characters long, numbers and letters, and that was the only thing in the string, then it would internally convert that to an object ID, so that in your Mongo database, instead of comparing with a string to a string, you'd be comparing object ID to string, and the comparison would fail. But when you tried to show either of those, it would just show you there was a string going in and a string in the database. And it's kind of, but they're the same type, and every other string would work, except those strings that were 24 characters long. Right? So emails were fine, and names were fine, and every other string you could imagine was fine except your ID, if you had a generated ID from a program that was generating a unique ID that happened to be 24 characters long. Right. Now, that was put in probably by somebody who just thought, well, you know, I just need a quick way of turning this string into an object ID so I can quickly find my object IDs without having to manually say every time, oh, this is an object ID, right? And thinking, well, you know, no other string is 24 characters long with like numbers in it and no spaces, right? No emails like that, nobody's kind of name is like that, so no other real string is going to be a problem, so let's just convert it to object ID. So they hacked it in there, did that, and that's been there since 2014 in the Angular library. And so now, and you know, it was identified in 2015, they went, oh, okay, well, you know, here's the workaround. So people have just been doing the workaround. And now they looked at saying, okay, there's a branch update for Angular you can try to see, which then doesn't do this hack conversion. But when you run that branch version, about half your libraries die because they were all using that hack as a way of automatically turning string into object ID, so they didn't have to. So, like, what do you do as when you've got like the way it should be done, which is not this hacky way, but because it's been that hacky way for so long, and lots of people have then used the hack that kind of they found, when you try and remove the hack, it breaks all of their code. What should you do? Okay, different categories. You as a developer, or you as the owner of the library, what should you do? So as a developer, what would you guys do? So you currently just use a workaround, don't use the new branch library, just use the old library with all the working APIs.
We'll see if there's a working way around to avoid it.
Well, the easiest way is to avoid 24 character strings, right? And just say, I will just make sure I never have a 24 character string, because I'll just append another character on the end of every one of my 24 character strings, so that there are now 25 characters and everything's fine. So yes, you can do that. That's a workaround, and keep the existing library.
If you have the time, or the company gives you time, you can probably make a fork and fix it and make a pull request.
Well, so that's what they have, right? So they have the pull request, right? So it's been fixed, but they're now at that position of, given the fix breaks all this other code base, do we implement that fix or not? So that then becomes the as an owner of an API, do you implement the fix and just then tell everybody to update their stuff, and if it's broken, it's just broken and they have to deal? Or don't you?
As the owner of the library, you can deprecate the method and then implement the new one, and then gradually fix the
So the problem is this isn't a function call. This is a thing that it does to the string that comes in, right? So this is behind the scenes. It's not something that I explicitly asked to happen, right? So when I change it, it changes in the background without. So I don't have a way of warning people that, oh, you're calling a deprecated function, because it's just in the background happening, right? So if they remove it, things just break, right? And even if it was deprecated, if deprecation just means it still runs but with a warning, then your old libraries will still run with a warning. But this one, converting that string, it like, if it does it, then it's done it. If it doesn't do it, then it doesn't do it. It's not a function call, because it's not something I could quarantine off in that way. So you know, that would be a reasonable way for a function that was being called that you want to get rid of, to start deprecating things. Though sometimes deprecating things doesn't work, because I think in first year you guys used deprecated functions and then told the compiler not to care. Yeah. So you know, even if you want to deprecate them, sometimes like the language where we're deprecating that, and the compilers go, well, you know, yeah, okay, we'll warn people it's deprecated, and oh, now we'll deprecate it, except if they turn off the deprecation, and then we'll use it anyway. It's gonna it's hard to get rid of. So, but in this case, what would you do? What would you expect a professional organization to do?
I think you should just fix it, because it's not your responsibility like all the other things people have.
Okay, so you would fix it,
yeah,
and then say everybody should just. So broken libraries, those need to be recompiled and updated.
I would probably look into another framework.
Well, this is what some people do when they get so annoyed at a particular framework and no, I'm not going to use that again, and they move on, right? But this partly comes into that issue of when you design an API, right? As you update it, what is the appropriate way of doing an update, right? And as you say, I mean, some people will move to a new library because this library just is broken. And unfortunately, you also worry that when it does one of those things behind the scenes, what else is going on that might trap you later that you don't know about right now. So how to do this update? Version numbers. Do you guys have a clear idea of what version numbers mean? So some of you feel you have a good, clear idea of your version numbering?
You normally have three numbers separated by a punctuation, where the most left ones means a major update, the middle one means a minor one, and the third one is typical patches or hotfixes.
Right. So with an API, when you do an update, those numbers are relevant, right? Because with an API, and particularly DLLs, right? The idea with a DLL is if you don't do a major update, your DLL should probably still work, right? Because if you're version 2.1 and you go to version 2.2, things that operate against 2.1 should still operate against 2.2, but you might have added some functionality, right? So usually those minors are, we're adding functionality, we're doing a bug fix, we're doing those sorts of things, but we're not removing things that were there. However, if you go from version 2 to version 3, you may actually remove whole functions, which means if you work against SDL1, you might not work against SDL2, right? Because I may have removed the functions that you call, right? So as a library writer, you have to be aware of the versioning you're doing. If you're doing DLLs, if you keep in your mindset, when I do a minor, I have to make sure all the calls that were there are still working. So if I add anything, it's fine. If I try and remove anything, no, that's a whole new major version update. Right? And then people might refuse to move to that version because it doesn't have the functions that their program relies on. Right? Because you're building a library, you're building something that other people rely on. And so you're doing this versioning and updating and deciding when to do an update. So with Angular, for example, once you've found that bug, you probably can't change it as a minor. Right? Because that's not a minor version thing. We're changing how this whole library works in the back-end way you can't have any access to, so it might break all the code that you have. Right? So that actually might, even though it's potentially a single line of code that you're changing, it might trigger a whole version number change in your system. Right? So, with the APIs and with developing your own libraries, what we want you to do, and we can do this in two ways. One, I can take you through building a library in Visual Studio, and we can show you the building a simple wee library in Visual Studio. I've got the example of the Google Sheets API. You've all used Google Sheets, I assume. Okay, so Google Sheets provide you with a relatively good API with OAuth integration that allow you to code against Google Sheets in the background, so that I can be writing code and I can be doing things on my website, or I can be doing things in my app or on my phone, and use Google Sheets as my data storage area. Right? And I can either connect it to my own Sheets, which is a little bit dangerous because, you know, then I'm allowing my users to use my data storage area, which you'd only do if you have Google as infrastructure, right? If you've got a professional account, that's a reasonable thing to do because you're paying for Google. But you can also do, just like you'd see in, you know, when you get some programs and they say, oh, do you want to sync with a Dropbox, or do you want to sync with Facebook, right? They do that OAuth thing of popping up do you want to allow this program to access your Facebook, blah, 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 when you log in, yeah? You've hopefully all done that. Well, you can do the same with Google Sheets, Google Docs, and it pops up with do you want this program to be able to see your Google Sheets? Right? And if the user agrees, you're then able to store data directly into their Google Sheets area from your website or your program that's running. All right? So I can directly link into the API for Google Sheets. Now, the example that I've gone through and we could go through is a Node.js example using JavaScript. But I was unsure how many of you would want to do that, seeing not many of you are actually using JavaScript this semester, and so learning a whole bunch of Node.js and JavaScript is kind of, I would like to build a library for my own stuff. So rather than force you to do it, like force you to do an exercise that I did, what I'm going to challenge you to do is, and come up over the next 15 minutes, I want you to sit in your groups and think about how you could take some of what you're developing and modularize it into a library, right? What that library would be and would look like. And then we'll come around after the break and discuss whether or not that's possible to do and how that might benefit the kind of the professional approach you take to your code. Because if you can find things that you can take out and then reuse, those are things you can also show people. Rather than I built this program and I built these libraries to be reused in other projects, or that are reused in this project in this way, right? So rather than just like copying, pasting code from one project to the next, which is what you currently do mostly, yes, right? You just, I'll just copy and paste the code, it'll be fine, right? Which, you know, yeah, it's okay, but it's still like copying and pasting, and it's duplicating, and, you know, when you've got a bug fix that you found, I've got this error, What do you do about all those other, this error in all those other programs that you'd been copying and pasting the program from? And then when you need the code again, which one of those do you find? Do you copy and paste it out of the one that still has the old code in it? Or, like, it's a bit hacky to do that. Right? If you were doing this professionally, you separate it out into a library that is your math library. You have that as separate code that you just include into other projects as a library. You want new stuff in your library? You put new things in your library. Right? And then, because that's the true base thing, when you go back to other code and reload that code, it still links into this new library. And if you've made something faster, that's great. Your old program now runs faster because your library's better. Right? So think about, what I want you to do is go and think about your project, think about what can be made into libraries, what could be separated out that is reusable. Okay? And I'll let you guys do that for 15, 20 minutes, and you can ask me questions about libraries, and I can show you some of the Google API if you want to after the break. Okay? Question?
Yes, why didn't the Discord thing work?
Because the guy who was sending me code wasn't able to do that in time.
Yes, because that sounded more fun.
Oh, the Discord thing will be fun as well, but yes.
So the Discord thing hasn't just been pushed, decided just when we have the time.
It's been pushed back rather than moved away.
Right,
Yeah,
I thought
yeah.
it was. We're gonna do
No.
Discord.
No. It's just been pushed back. Yeah. Because yes, we're there is an API for Discord and stuff.
Yeah, I know.
Yeah.
And like Discord is the current hot thing, so it would be fun to talk.
That's why I was trying to do that. But yeah, no, because one of the guys here has done some Discord stuff. So yeah.
Since like most major companies has some sort of API, I know Riot Games, League of Legends has one. That's just JSON.
Yep. Yep.
And one of the problems with APIs, and I even can attest for this, was when they updated the API during our exam. Yes. It was fun.
Yeah. Updating the API during the take-home exam. Yeah.
Yes. I was so.
You really struck gold that day.
I mean, it was a really small problem, but it was like, okay, this worked yesterday. The fuck?
Yeah, no, that's very unfortunate. That's usually not the case, but
Did you find out why they did that? Because they just changed location to things. It didn't make any sense.
Learn since there is it happens randomly. It's two topics that change position.
Because the one day it worked.
And then it doesn't work and then it works again.
It was just strange.
I will just stop the streaming while